Maintaining steady fluid velocity and sharp, clean peaks is a constant challenge in production laboratories. When a proven method displays wide peaks, a drifting baseline, or high back pressure, operators often blame chemical or solvent quality. However, minor structural failures within internal support screens are usually the true causes of downtime, disrupting fluid dynamics and dispersing samples unevenly. To resolve these bottlenecks, operators must focus on the boundary layer where the mobile phase enters the stationary resin. A uniform flow prevents physical shifts inside the column bed, maximizing separation efficiency. High-quality column internals protect expensive stationary phase materials, lowering cost per injection while extending instrument lifespan. Chromatographic resolution relies on sharp, separate peaks as sample compounds rinse through the packed resin bed. Decreased resolution or baseline drift typically stems from band broadening, the physical spreading of the sample zone. This occurs when an uneven fluid front forces sample molecules to take unequal paths, creating overlapping peaks. To stop this dispersion, the design and open area percentage of the bed support are critical. Restricted open areas or uneven pores force fluid through the screen at high velocities, creating a jetting effect and turbulence that distorts the sample plug. Conversely, a high open area with a uniform grid pattern ensures a smooth fluid transition across the column diameter. This minimizes physical obstructions, equalizes path lengths, and keeps sample molecules moving in narrow bands. Controlled open area also eliminates dead zones where stagnant fluid traps molecules and causes peak tailing. Custom woven wire mesh solutions like Porostar addresses these challenges by ensuring smooth fluid entry to eliminate jetting, providing a zero dead volume design to eradicate sample trapping pockets, and delivering sharper peak separations that maximize peak capacity. Unpredictable pressure fluctuations threaten data consistency and stationary phase longevity. In HPLC and FPLC systems, a steady flow rate is required to ensure reliable retention times. Pressure spikes after mobile phase velocity, disrupting elution windows and forcing manual recalibration. This physical stability of the internal bed support directly establishes this baseline pressure. Standard porous metal frits feature irregular, winding pathways that easily trap debris and dried buffer salts. As blockages accumulate within these pores, resistance climbs, driving up back pressure, overworking pump seals, and triggering unexpected shutdowns. To prevent these issues, column filtration must employ a pore structure that facilitates easy fluid passage while offering rigid structural support. Woven wire mesh features a straight-through geometric pore layout with no internal dead ends, allowing complex biological samples or high salt buffers to pass with minimal pressure drops. Additionally, a rigid calendared stainless steel mesh ensures the boundary layer remains flat under continuous load, stabilizing retention times and protecting pump components from premature wear. Channeling and resin media loss are serious mechanical failures that permanently degrade column performance. Channeling occurs when the mobile phase finds the path of least resistance through the packed bed, creating rapid microstreams that bypass the stationary phase. This disrupts mass transfer, leading to split leaks, asymmetrical shapes, and a total loss of separation power. Channeling typically originates from uneven flow distribution or physical shifts in the underlying bed support. Weak spots or inconsistent pore sizes create localized velocity variants that cause the resin bed to shift, crack, and form gaps that erode the surrounding structure. Preventing this requires a support structure providing uniform flow resistance across its entire surface. Structural failure also leads to the mitigation and loss of stationary phase media. If pore openings exceed the size of the smallest resin beads, particles bleed through the support layer, lowering bed height and creating permanent voids. Escaping particles travel downstream, risking contamination to delicate detectors, valves, and final products. High-precision woven wire mesh filters like Porostar solve this by forcing identical fluid velocity across the bed cross-section to eliminate channeling, ensuring total particle containment, and stopping stray media migration. Thanks so much for watching. If you have any questions, click on our Talk to Us button to get in contact with our many experts on woven wire mesh. And if you'd like to learn more about woven wire mesh or our many products, we have a learning center filled with written and video content to make you an expert. We also have a YouTube channel. And don't forget to click that subscribe button and ring that bell to keep up with all things Hover and Boker. Once again, my name is Andrew Kotlar, and I'll see you around in the next video. Bye for now.